Hello again. This is the course of data structure and algorithms, and we are going to continue our previous discussion about stack. Okay. The last time we already learned about the basic concept of stack, like the abstract data type and some examples of stack. And I'm going to continue the things that we learned before. So the examples about parenthesis matching. Okay. I guess you still remember when we are having a problem to match those parentheses, the, this bracket and curly bracket and square bracket. And I would like to find the match between them. Then, yeah, if I can find the match, it will show true if it is match. If it does not match, then we will give the false. Yeah. So the examples already given before, you already look at the Python file. There's another example about how to use stack. So for example, here is about the HTML tag matching. I'm not sure if you're familiar with HTML, but HTML is one of the programming language which is purposely for the web. Okay? So HTML means hypertext markup language, and this markup language needs a beginning of tag and ending of tag. So the beginning of tag, usually it should have the triangle bracket like this one, name, and then there should be also an ending tag like this one, name, but it should have this slash. Yeah. So if you start with name, then it should end with name with slash. So if I have body, for example, this is the beginning of the body, and then this is the ending of the body. So the ending of the body should have slash to indicate that this is already the end. And also the same with the other things, so like for example, center, and there is also slash center, h1 and slash h1, and so on. So we need to find the pair in order to make the web clear. Yeah. Now, how can we do with this HTML tag matching? So we can also use the stack, and the use of stack is um, more efficient rather than you use the for loop, for example. So this is the case. I think I will go to the Jupyter Lab. Um, okay, let me run again. Maybe because you're doing this video for the first time, so I guess you need to run also the uh, code that I give to you. The first code is about the stack, array stack, and then the second is about the is match, which is about the parenthesis match. Yeah. And the next one is about the match HTML. Yeah. So if you try to do this one, okay, yeah, this is the array stack. So we are creating one array stack. The array stack is from the first code that you already saw, and then we are going to find this triangle bracket. How can we find this one? It is from the raw. Raw means, yeah, something that you want to give. For example, if it is string, then it is finding the something in the string. Okay. So if j is not equal to 1, then sorry, if j is not equal to -1, what is -1? It means you will try to find all the element in the string. Okay. If the element on the string is already -1 or is not empty, but the number of array in mm, the string is already in the -1, because you know that the array start from 0 until n, so it will never be -1. If it is -1, then it will not enter this statement. Or yeah, if it is not -1, then yeah, you will do this one. And then what you will do is, if you find the triangle bracket or the closing, then just go to the next. Okay. And then if k equals to -1, then false. If k is not one -1, then you will do the tag like this one. The raw is something like j plus 1 until k. So I want to go for the next element from the j plus 1 until the k. And then we need to check if it is not starting with the slash. Okay, if not, yeah, you already learned. If not, so if not tag start with the uh, slash, then let's put on your stack push. Okay, so you put, and then if it is true, if it is false, okay, so what is false? If it is false, then it means there is a slash. So if you have the slash, then let's check. If it is empty, then it's written false. If not empty, then let's check the next one. And is if it is not equal to the pop, then false. What do you mean? Okay, what does it mean by this one as pop? So if we have the stack, if the element in the stack is not equal to the tag that we already push, then it will be false. And yeah, next you will need to find another opening bracket. So this is the next element or the next tag in your HTML file. So if I let's check if I run this one, yeah, so the things here is true because I have HTML and then I have the ending of the HTML. If I have HTML and body, yeah, so here is false because as every name in the tag should have the same ending tag, okay? HTML and body, so it doesn't match. So let's see if I don't know if I try with another. If now I have, let's see, yeah, I have HTML, okay, and then I have another like body, and then I have this body, okay. So I have two tag, like see. So if I run this, okay, it's true because the beginning of the tag HTML has the ending HTML, and the body of the beginning of the body there is also another ending. Okay, then it is true. So another possible implementation for stack is about the arithmetic expression. What is arithmetic expression? Let's say you have this expression 14 minus 3 multiplied by 2 plus 7. And yeah, you know, in the computer programming, there is an operator precedence. It means multiply has precedence over plus or minus. So if it is like this one, my 14 minus 3 multiply 2 plus 7, then it means I will do the multiplication first. Okay, I will do the multiplication. After I do the multiplication, and then yeah, I get, for example, this is the what is name, the result is 6. Okay, then you will go from the left to the right, so you will do 14 minus 6, which is 8 plus 7, then the result is 15. Okay, so the result of this mathematical operation, yeah, you know by your intuition. Yeah. But how can the computer understand this step? Okay, then yeah, we need to understand some basic mathematics, like for example the associativity. So operator of the same precedence group, yeah, evaluated from left to right. Yeah, so you understand this one. If they are in the same precedence, then it will start from the left to right. If they are different level, then it should be the priority. So the idea is push each operator on the stack, but first pop and perform higher and equal precedence operations. So what does it mean? Yeah. Let's check with this example. So in this mathematical operation example, there are 1, 2, 3. Okay, there are three operations. Okay, the first operation is do op. Okay, and the second operation is repeat op, and the third operation is the evaluation expression. So the do op is a way to pop, okay, and pop. It means we are try to remove the element, okay. And if we are doing the repeat ops, okay, so this repeat ops, if the size is greater than 1 and sorry, maybe the format is not that good, but yeah, I can explain. If the size of the value stack is greater than 1 and the precedence of the reference operation is less than the precedence of the top, okay, so if we have the, like, if we have this stack and then we have 1 2 3 4 5, for example, okay, so if the reference operation is less than the precedence of the top, then to up, okay, so we will do this method, okay, so it will be repeated until the condition satisfy. And you can see here when we want to do the evaluation for the expression, so we need to check, well, there's another token Z. So what is that token Z? So we are going to push the Z, and yeah, if it is a number, then push in the value stack. If it is not number, then we will do repeat ops. Okay, we will do repeat ops, and the repeat ops is placing the Z. Z means the operator. Okay, so it means we have two stacks. Okay? The first stack is for, we have two stacks. The first stack is for the operators, and the other stack is for the values. If it is, for example, okay, we have 2 plus 1, and what is the value? This is the value. Okay, this is the value. And what is plus? So this is the operator. Okay, then yeah, we can do something about the value if it is a number, and if it is not a number, then we will do the operation, and then we will push. So it means we will store the operator into one stack. So this will be in the repeat ops, and it will be repeated until you get the result, and then let's return the value stack top. Yeah. Now I think it's better to see from the example. Okay, I have 14 less than equal 4 minus 3 multiplied by 2 plus 7. Okay, and we know that if we are doing with this operation, we will do the multiply first and then minus and plus will be later. But what about this? Okay, what about this? Less than equal. So the less than equal has a lower precedence than plus minus. Then it means it will be at the last one. So it's the last one to be operated. Then we can check. Now because this is less the last one, okay, so we will check from this part. Okay? So 4 minus 3, okay, then I will have this one, okay, if I have the first stack, okay, this is the first stack of the number, so I will put this one 14, okay, I have 14, and then I will put this operator as the less than equal, and then I put 4, okay, and then I put minus. Okay, so this is the result. Okay, so this is the result. And then after I finish this one, I will check the next one, which is 3, okay, and multiply. Okay, oops, yeah. So I have 3 and multiply. So this is the operator. Okay, this is for the operator, and this is for the number. Okay, and then I will do again like this one. So I have 2. Okay, and okay, now I know that this operator star is the precedence. Okay, then when I want to put the new operation, which is plus, so I will consider the plus and the multiply, which is higher in the precedence. So because I know that plus and multiply is higher, so I will do 2 multiplied by 6, 2 multiplied by 3, then what is the result? Result will be where's the result? Okay, so 2 multiplied by 3, then we will get the result is 6. So we put this one into 6. So this is the result. So after we check, because multiply has the higher precedence, we check plus. What is plus? Okay, then I guess plus can be inserted here, because plus and minus, they are the same. But before we are doing the plus, we need to do from the left. What is the left one? So right, plus and minus, so we need to do this one first. So it means we will do the 4 minus 6, okay, because this is the left, and then minus, and then 6. So the result will be minus 2. Then I can just update this one, eraser, and then this one. Yeah, then I can put the number minus 2. Okay, after I have minus 2, yeah, because it's empty, then I can put the plus here. Okay, and what is the plus next? Is the 7. Okay, so I put 7 here, and then yeah, I need to delete this one. So when I have the 7 minus 2 plus 7, what is the result? Then it is 5. Okay, minus 2 plus 7, then the result is 5. If I have 5 now, yep, the result is, yeah, for this one, the result is 5. And then I would like to check 14 is less than equal to 5. Then we know that it is not correct. So this is the result of this expression is false. Okay, yeah, you can get this one is false. So this example, yeah, the mathematical operation is one of good example for using the stack, and we can also use another example for how to optimize the algorithm using stack. As I explained to you, we are using a book. This is the PPT that I took from one book, which I explained in the beginning of the page. But this example is not in the book. Okay, so if you have the book, you can also see all the other examples on the book. But for this one, there is no example on the book, so I just want to explain, and hopefully it will help you to understand how can we optimize one algorithm using stack. So stack, as you know, it is an auxiliary data structure in algorithms. And when you have an array, for example, okay, you have array X, we want to say the span Si of Xi is the maximum number of consecutive elements Xj immediately preceding Xi and such that Xj is less than Xi. Maybe you confused with this word. So let me just explain like this one. Do I have an example? Oh, okay. Let me explain like this one. Now, we have the span Si. Okay, this is S. Okay, this is the S, and then Xi. Then it is the X. So dx X means this is the value of the stock. Okay. Yeah, this is just just a number. Okay, we have 6, we have 3, and then we have 4, and then 5. We have 6. Okay, 3, and then 4, and then 5, and 2. Now, I would like to check the maximum number of consecutive element xj immediately preceding xi and such that xj is less than equal to xi. Okay, what is this? Xj is less than equal to xi. Xj. So let's say we have j equals to 0 because yeah, xj immediately preceding xi. So I equals to 1. Okay. Now I would like to check if it is 6. Okay. X0 means 6. So 6 is less than equal 3. Okay. So if it is not the case, then yeah, 6 is not equal to 3, then yeah, you can just keep the number as 1. Okay, and then we will go j now becomes 1, and then I becomes 2. Okay, what is the result? Now we are checking 3 is less than 4. 3 is less than 4. Yes, it is true. Okay, this one is false. Because it is false, then you will just keep the number as 1. Okay, and then now 3 is less than 4. Yes, it is true. Okay, then yeah, we can have this one still 1 for the index 3. Okay, and then let's check again. We will move this one into 2, and then we will move this one into 3. What is 2? 2 is the element of the index 2 is 4, and the element of index 3 is 5. Then I want to check whether this one is this one. Okay, because this is true. Okay, true, and then we have 1. So this one is 4 less than equals to 5. Okay, 4 less than equals to 5. Yes, this is true. So the condition is true. Then I would like to know if the number is increasing. Why I want to know the number is increasing? Okay, let's see later. So 2. Now, okay, now it becomes 2 because I would like to increase. I would like to just do the plus 1. So there is an increment because I know that the number is increasing. It means if you want to check, let's see, if I want to go to the next one, is this 3 and then 4. Okay, what is the number of 3? So we have 5. Okay, and then we have 2. Okay, it means you need to check if it is okay, it is still in the position. Yeah, so because oh sorry, this one should be x s i x I. Okay, because this is one xi. Okay, so I need to check this based on this one. So if it is true, because this one is false, oh maybe I need to revise my statement. Okay, maybe it's not okay, maybe it's for clear. Maybe I can just make the so when it is 6 3, then the s1 is equal to okay, the s1 will equal to the maximum number of consecutive elements. So we have only 1. Okay, because we don't care about the s0. When we have the when we have 3 less than 4, okay, for the index 2, we have the number of consecutive element. When we have this one, then yeah, it is the next one. So because we have this is after the 1, okay, we have the next one which is true. So I would like to increase now because we have true, we have true condition. And then what is 4 and 5? Okay, so this one will be the index 3 because it is true. So I would like to know because it is already true. So the index 3, the number will be increased by 1. When we have the 5 less equal than 2, okay, so this element will go back to 1 because I know that the number of stock now is decreasing. Because I know that it is decreasing, so let's return back to 1. Okay? And if I know that it is already 1 again, then it starts from the beginning. It starts from the beginning. It starts from the beginning. So it is like this one. If I have a flow and then go down, and then go down, and then go down, and then go down, what happened? Then I would like to have known about this situation. If this situation is always occur, so it will be returning to 1. It will be returning to 1. It will be returning to 1. And then maybe okay, you need to sell your stock. Okay. So the algorithm is something like this one. If you have array x of n integer, and the output should be s of span of x. Now, first, I would like to put all the n integers in the s. So in the s, it means the array. Of course, you know, the array consists of n elements, so there will be n operations. And I would like to do the loop from I equals to 0 until n minus 1. So there will be n operation. S is 1. Okay. So because this is the loop, okay, I said to you before, if it is a loop, so we can say it has the n operation. Now I would like to check if s is less than I and xi minus s is less than xi. So the operation here, so we have this as the loop. Okay, this is a loop again. So I would like to loop until n minus 1. Why this n minus 1? Because I will do the loop like s, this is s plus 1 until the condition we got is like this one. So it means you will check all the numbers in the array. If you check this one, we have n and then we have n minus 1. What is the on? Yeah, we can just easily figure out this is n and then this is n. So it is n multiplied by n. Okay, so there is n time, and then we will do looping for another n time, so it will be n power of 2. Okay, so if it is n power of 2, then can we compute with stack? Would it be better if we use stack? Okay. Now, if we are doing with stack, we need to have the idea how can we look back. Yeah. So the first algorithm before that I mentioned to you, it was just two loop, okay, or nested loops. If you're doing with the nested loops, yeah, of course it's easier to understand, but it's not efficient because it is n power of 2. And if I want to make it more better algorithm, you can check with the stack, but we need to understand. Let's scan the array from left to right, and then let I be the current index, and then let's pop the index from the stack until we find j. Okay, what does it mean? Until we find j. So we have the condition: if xi is less than xj, then yeah, we need to set the I as I minus j, and then we do the stacking. Let's see. So with this linear algorithm, okay, I have the S as the new array, so there will be n times, and then I have the A as the empty stack, okay, and then I would like to loop, okay, I would like to loop from I equals to 0 until n minus 1. Now I will do the while loop. Okay, this while loop is in the, yeah, in this block. Now what you can see here is now I'm doing with a very simple stack. If it is not empty, and if the x in the top is less than xi. Oh, okay. So every time I have a value, then I will just put it on the top. If I don't have any value, yeah, if it is not empty, and if the condition in the x at top is less than xi, then pop. Okay, and then if a is empty, then let's check the next one. If not, then let's make the si, which is the next integer, as the I minus the top. Okay, and we have push I. What does it mean? We want to put the element I. So if we can see this process, actually this is only checking, okay, but there is no addition. There is no addition for this while loop, and then we want to get this n. Oh, maybe this is not the, okay, during this one, we will only do this part, and then I will do this part, okay, sorry, I will do this part, and then this one part, this part is different. So if I have the I, now we have the empty A, then we will check the next one. If it is not, then I will check this number. I will assign the value I, which is from the top, into this one. So you can check this one. This one is only n times. Why it is only n times? Because you don't have any checking for the next step. You don't need to checking like what you already did for the first one. In here, you will do for every s when the s is added by 1. So there will be 1 until n minus 1 time. But for this one, there is no additional. So you just check your stack, whether the stack is empty or not. If the stack is empty, then you can go to the next. If stack is not empty, then yeah, you will do checking, and then yeah, you will do whether you want to pop or you want to go to the next one. Okay. So if you check this algorithm, you have n, 1, n, 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 and n1. So this resemble that your algorithm is ON. Okay. Maybe you can check from the code. It will be easier to understand the code. Yeah, this is the span one. Okay, so the span one is the algorithm. It's not division. You can check if I create a list. I want to run from I, which is the range of length of the x, and then I would like to check. I want to start as with 1. So this is the case. You will check for every s. Okay, so every s, if the condition is still xi is less than xi minus s, which is less than xi, then you will just adding. Otherwise, you will do this one. You will append the s into the list. If you have span 2, 6, 2, 4, 5, 2, then the result will be 1, 1, 2, 3, 1. So it is the S. Okay, this is the list that you created. Now, if I want to use the stack, okay, so I use the stack. So the result for the for loop is the same, but the while loop is different. Okay, so this while loop, it is not a real loop. Okay, it is not a real loop, but it is only to loop if the condition is true. Oops, sorry, I changed this one. Okay, if the condition is true, then I will do loop. But what is the condition here is about the stack. Okay, and you know the stack will not be so many, because in this case the stack will have only 1 or 2 or less than n. Okay, so because we have less than n, if the a is empty, then we will add the s with plus 1. If not, then we will check the I, and then we will minus with the number of element in the stack. So we will just keep adding I, and we will check whether the condition is satisfied or not. So if I run this, case with the element here, okay, the same element here, the result is the same. But the difference is the number of complexity. So if you're using this complexity, maybe it's easier to understand, but the complexity will be O n power of 2. If you use this stack, then the complexity will be O n. In this case, of course, I would like to choose the O n, or which is the better one. But in order to make this algorithm, you need to really understand the idea, so that the things can happen with the stack and the algorithm can be more efficient. So the case here is not every algorithm you can use stack. You need to understand how the algorithm works, and of course you need to design like this one. How can you put the array, yeah, and then how can you arrange from left to right. So you need to know the sequence, and you need to know how can you use array for this element and dash element. When you know that design, then you can use the stack for your algorithm. Okay. So this is the end of the stack chapter. It is about the basic abstract data types, and then how we learn also the some stack example, and then we can know also how the stack can be used to optimize the algorithm. Okay, so I will continue with the other video, and the next video will be about the queue, and we are going to meet again with the other video, and we will meet again with the on real-time class. Okay, thank you for listening. See you.